Hi, welcome to this Corbettmaths video. In our last video, we looked at the laws of logarithms. So we looked at these laws of logarithms in our last video. And in that video, we looked at some questions involving numbers, and we also looked at some questions involving algebra. But I also mentioned in that video that I would then do a video showing you where these laws of logarithms come from. So let's start off with our first law of logarithms. The fact that log to base a of x plus log to base a of y is equal to log to base a of xy. In other words, if you're adding two logs with the same base, you can multiply the numbers together. So it'd be log to base a of x times y. So let's look at that law of logarithms. So there it is there. And to start off with, what we're going to do is we're going to let log to base a of x be equal to m, and we're going to let log to base a of y be equal to n. So we're going to let this be equal to m and this be equal to n. Now if we let this be equal to m and this be equal to n, we can actually rearrange this, because remember, if we have something in index form, we can write it as logarithms. So that means if we've got something in the form of logarithms like this, we can write it in index form. So let's write this in index form. So remember, log to base a of x is equal to m. So this is the base, this is the power, and this is the answer. So a to the power of m is equal to x. So let's write that. A to the power of m is equal to x. So we've let this be equal to m, and we've just written that in index form. A to the power of m is equal to x. And likewise, if we look at this logarithm, log to base a of y is equal to n. There's the base, that's the power, and then that's the answer. So a to the power of n is equal to y. So a to the power of n is equal to y. Now what we're going to do is, this is x and this is y, we're going to find xy. So we're going to do x multiplied by y. So let's find xy. So xy. So xy would be x multiplied by y. X is equal to a to the power of m, so that's a to the power of m. And then y is equal to a to the power of n, so that's a to the power of n. And we're timesing them together because xy means x times y. So I'm just going to put a multiplication sign in there. Now think back to your GCSE maths. If you have a to the power of m times a to the power of n, if you've got things with the same base and you're multiplying them together, you can then just add the powers. So this would be equal to, let's just add the powers here. We'd have the xy would be equal to, and adding the powers, we would have a to the power of m plus n. So for instance, if this was to the power of 10 and this was squared, you'd have a to the power of 12. You'd add the powers together, so it'd be m plus n. So this is fantastic. We've now got the xy is equal to a to the power of m plus n. Now here, if we have a look here, we've got something in index form. We can write that as a logarithm. So let's write this as a logarithm. Let's write this as a logarithm. So this is the base, this is the power, and this is the answer. So let's write that as a logarithm. Log to base, well, the base is a, of, well, that's the answer. That'll be xy is equal to the power, and the power would be equal to m plus n, so m plus n. So we've got log to base a of xy is equal to m plus n. So now if you have a look at this, we've got log to base a of xy. Well, if we look at what we're trying to prove that log to base a of xy is equal to log to base a of x plus log to base a of y. Well, actually, we're almost there, because if you look here, we've got log to base a of xy, so log to base a of xy is equal to m. But at the very beginning, we let log to base a of x be equal to m. So m is log to base a of x. So instead of m, I'm going to write log to base a of x. So log to base a of x. And then we have plus n. But n, remember at the very beginning, we let that be equal to log to base a of y. So instead of writing n, I'm going to write log to base a of y. So log to base a of y. And that's it. We have got here log to base a of xy is equal to log to base a of x plus log to base a of y. And that's what we're asked to prove. And just to recap that, we let log to base a of x be equal to m, and we let log to base a of y be equal to n. We then wrote those logarithms in index form with the base, the power, and the answer. The base, the power, and the answer. We then found xy by multiplying those together. So xy is equal to a to the power of m multiplied by a to the power of n. Then remember, whenever we multiply things with the same base, we can add the powers. So that means that xy would be equal to a to the power of m plus n. And then, because we've got something in index form, we can write it as a logarithm. And then that would give us the log to base a of xy would be equal to m plus n. And at the very beginning, we let m be equal to log to base a of x. So we replace that. And n was equal to log to base a of y. So then that's it. And that's it. We've just proved the first law of logarithms. Okay, let's have a look at our next one. Okay, so our next law of logarithms is if we're subtracting, if we do log to base a of x, subtract log to base a of y, that's equal to log to base a of x over y. Okay, so let's look at that one. So here's that law of logarithms. And again, we're going to let log to base a of x be equal to m and log to base a of y be equal to n. Okay, now we've got two things as logarithms. Let's write them in index form. So base, the power, and the answer. The base, the power, and that's then the answer. So a to the power of m would be equal to x. And here we'd have the base, the power, and the answer. A to the power of n is equal to y. Now what we're going to do is we're going to do x divided by y. We're going to do x over y. So we're going to take our x and we're going to divide it by y. And I've just done it over because in the question we can see we've got an over. And then x, well, x is equal to a to the power of m. So it's going to be a to the power of m. And then that's going to be divided by, and then y is equal to a to the power of n. So it's a to the power of n. So we've got the x over y is equal to a to the power of m divided by a to the power of n. And remember, if we have a to the power of m divided by a to the power of n, we're dividing with things with the same base, so we can take away the powers. So that'd be a to the power of m subtract n. We can subtract the powers there. So that means that x over y is equal to a to the power of m subtract n. Okay, so this is now fantastic because we've now got something in index form. So now let's write this as a logarithm. So if we write this as a logarithm, we've got log, the base, well, the base is a, and then we then have the answer, so that's going to be x over y, and that's equal to the power, which is m subtract n. So we've got the base, the power, and the answer. The base, the power, and the answer. So that means we've got log to base a of x over y, well, that's there, the left-hand side, is equal to m subtract n. Now this is fantastic because remember in the question we let m be equal to log to base a of x, so we can substitute that in there, and instead of the n we can write log to base a of y, so that can go in there. So let's do that. So that means that log to base a of x over y is equal to, instead of m we've got log to base a of x, and then we've got subtract, and then log to base a of y. And that's it. So we've just proven that if we have log to base a of x and we subtract log to base a of y, that's equal to log to base a of x over y. And that's it. We've proven that second law of logs. Okay, let's have a look at our last one. Okay, so let's look at our last law of logarithms. That's the fact that log to base a of x to the power of n is equal to n log to base a of x. So what I've done is I've let log to base a of x be equal to y, and I've just chosen a letter of the alphabet here. I've chosen y, and actually you'll see later on it's quite handy if actually this letter is a bit later in the alphabet after n, and you'll see why later on in this proof. So let's have a look here. We've got something as a logarithm. Let's write it in index form. So we've got the base, the power, and the answer. So a to the power of y is equal to x. Now I'm going to turn this around. I'm going to write x is equal to a to the power of y. So we've got x is equal to a to the power of y. Now what I'm going to do now is, if we have a look here, we want x to the power of n. So I'm going to raise this x to the power of n. So I'm going to write x to the power of n. And then if we've got x to the power of n, we also need to raise this to the power of n as well. So I'm going to put a bracket, a to the power of y, and that's all to the power of n. So I've raised both sides of this to the power of n. Now let's just scroll down a bit here. Okay, now if we have a look here, we've got x to the power of n is equal to a to the power of y all to the power of n. And if we think back to our laws of indices, if you've got a power of a power, you multiply the two powers together. So we've got here x to the power of n would be equal to, and then we're going to times the two powers together, so it'd be a to the power of yn or ny. So I'm just writing that as a to the power of ny, just putting those two powers together. Now here, if we have a look here, we've got a base, a power, and an answer. So what I'm going to do is I'm going to write this as a logarithm. So log, we're going to do the base, well, that's a, and then we've got the answer, that'll be x to the power of n is equal to the power, that's ny. So we've got the base, the power, and the answer. The base, the power, and the answer. So we've got log to base a of x to the power of n is equal to my. Now, if we have a look here, we're trying to show that log to base a of x to the power of n is equal to n times log to base a of x. Well, the left-hand side, we've got that, fantastic, and we've got that's equal to my. But if we go back to the beginning of the question, we let y be equal to log to base a of x. So we're going to replace y with log to base a of x. So let's replace this y with this. So we'd have a log to base a of x to the power of n is equal to, and then we've got n, and then we're going to replace the y with this. And this is why I let it be equal to y, because I wanted the y to be here, so when we replaced it, we didn't have to turn it around. So instead of y, we're going to write log to base a of x. And that's it. That's what we're asked to prove. So we've shown it. So we've shown that log to base a of x to the power of n is equal to n log to base a of x. And that's it. And that's it. So in this video, we've looked at the laws of logarithms and where each of them come from. And each of them, we've used the laws of indices to work them all out. And that's it.